Alright, we've learned how to do 1 through 10. That was the easiest type of balancing. But we're going to step up the difficulty quite a bit here. And honestly, these aren't much more difficult unless you didn't pay much attention or bother to... Alright, sorry about the interruption. As long as last chapter you did your homework and you did well on that test, these should not be that much more difficult for you. You need to use your naming schemata to find the formula of these chemicals, and then it's quite easy. As you do this more and more, it should become even easier, and you might not necessarily need your naming schemata. But let's just look at number 11 here. In these sets of problems, you're going to have to write the identity of the chemical or the substance, aluminum, plus chlorine. Now, this is where a lot of fundamental errors start to appear. You have to remember all the way back from first trimester that when chlorine is alone, it's not alone because it's a diatomic element. If you remember from this one, chlorine had 7 dots, right? Alright, so it wanted one more dot. If 2 chlorines can get together, they both have 7, they share each one, then they both have 8. That's why chlorine is a diatomic element. Alright, so when it's alone, it's Cl2. Then we form aluminum chloride, AlCl. Now, I've used the term balanced charges. Aluminum chloride is not AlCl. We have to account for the charges of each so that we know what the ratio of one is to the other. If you recall, aluminum is in family 3. I'm going to put the charges above the words. That's okay. It's a plus 3. Chlorine is in family 1, or sorry, it's in family 7, which means it's 1 away from 8, so that makes it a minus 1. And once you have these charges written above, then you just switch their positions. The 3 above aluminum goes with the chlorine, and the 1 with the aluminum goes with the aluminum. Or, I said that backwards, but you know what I mean. Alright, so I'm going to take the 3, put it with chlorine, and I don't have to put the 1 with aluminum, because if I don't have a number there, it's implying that there is just 1. Alright, so now I've done the hard part. Now I just have to balance. If you remember in one of the previous video lectures, if I see a 3 and 2, I should do the swaparoo. If I have the same element and on one side it has a 3 and on the other it has a 2, you just switch the positions of those numbers. So the 3 on this side goes in front of the 2 here, and the 2 on this side goes in front of the 3 here. That makes 2 aluminums finally, so I put a 2 and I'm ready to go. 2, 3, 2 is how this would be balanced. Let's do this next one also. This next one's different. Let's talk about the type of reactions real quick. If you remember, on your naming schemata, we worked through a whole day of notes here. We talked about the 5 different types of reactions. Some of them have very specific ways that they react, and some of them don't. The first one that we just barely did, I better look at it again. Those 2 things forming 1. If I look at my notes, here I have 2 things right here forming 1 thing. So the first one was a composition reaction. I'm just going to write comp. Alright, now this next one is what's going to be called a double replacement reaction, where 2 compounds react with each other. Alright, here I have sodium hydroxide. I'm not going to have time to finish it, but we'll start. It's Na. I'm just going to wait, do it on the next video.